think we're ready to start. Welcome, everyone. It's a pleasure to have you here. I am Professor Amparo Galindo. I'm a professor of physical chemistry in the Department of Chemical Engineering. I have also the pleasure and privilege to be the director of the Institute for Molecular Science and Engineering, that we call IMSE for short. So in IMSE, we are one of 7 Grand Challenge institutes of the college, and we work with the remit to facilitate transdisciplinary research with a focus specifically, in our case, of tackling global challenges where molecular input is specifically important, either because the precise molecule is important or because we need to forward an understanding of how to develop molecular approaches to provide solutions. So we work together across faculties in the college with an aim to accelerate the pace of development of solutions in this context. And so, as part of the remit of our work, we produce briefing papers such as the one today. It's really a pleasure to be here with you, and with many thanks for the team that have put the paper together. And with this, I will pass the microphone to the chair of the day. We are very honored to have you here, Mala. So the chair for us today is Professor Mala Rao. She's extremely distinguished. I will read just a few of the highlights of your CV. She's the director of the Ethnicity and Health Unit and Senior Clinical Fellow in the Department of Primary Care and Public Health of the college. She is also the chair of the WHO Southeast Asia Region Expert Group of Environmental Determinants of Climate Change and Health. And importantly, especially for our paper today, she's the vice chair of WaterAid UK. So as I say, it's really a privilege to have you here, and thank you for your support of the Institute. And with this, I hand over to you.
Well, thank you so much, Amparo, for that very generous introduction. Let me add my own hello and welcome to the Institute for Molecular Science and Engineering's briefing paper launch, using microbes to remove microplastics from wastewater. I'll be chairing today's session, including the panel discussion, and it's a huge privilege to do so, Amparo. Today I'd like to welcome an online and in-person audience. I'm old enough to remember a time when plastics weren't everywhere, and my mother would walk home with groceries in a paper bag or a cloth bag, and I'd walk beside her with carrying some of those. And then I remember the excitement of when clear plastic bags became available, and it was such a novelty, and I could hand out my birthday favors and birthday goodies in these clear plastic bags. But now fast forward to today, and plastics are literally everywhere. In recent years, the pervasive use of microplastic pollution has garnered significant attention due to its potential threats to both human health and the environment. Our aim today is to foster a dialogue among key stakeholders, including representatives from academia, water companies, and the general public. By examining the potential merits and drawbacks of introducing plastic-degrading microorganisms into wastewater treatment processes, the panel will reflect on the viability of the solution in mitigating the risks associated with microplastic contamination in UK agriculture. And we very much want you, the audience, to join in that discussion. So to start this afternoon's program, we will hear a presentation from Dr. Jose Jimenez, reader in synthetic biology in the Department of Life Sciences at Imperial College London and co-author of the briefing paper. We will then go into the panel discussion. So I'm now going to hand over to Dr. Jose Jimenez. Jose, the floor is yours.
What's the clicker? Oh, yeah. Thank you. Okay, thank you very much, and good afternoon, everyone. It's a great pleasure to be here presenting this paper that we've written on behalf of the team. And we are going to be talking, of course, about plastics, and I want to start by saying something that might be slightly controversial, so maybe not for this audience, but it could be considered as very controversial. I want to say that plastics are great materials. Plastic is fantastic. And there are several reasons for saying that. So we know we use them a lot for because they have very important properties. So they're lightweight, so we can move things around at a low cost using not too much energy. They have incredible good water barrier properties, so we can use them to move liquids around, something that technologically has been challenging throughout the history. And they're very durable. We can use them, for example, to expand the shelf life of our food for a very long period of time, so we don't have to worry about producing too much or having too much waste. They're also very durable, and that's perhaps the biggest problem, the reason why we have to tackle plastics today. So I don't have too many figures in the presentation, but I want to start with one. So this is the amount of plastics that, according to some recent statistics, we have produced in the year 2022. And now I want to make a confession, so I'm terrible with big numbers. It feels like this is a lot, right? But I don't know how much of a lot it is compared to other things. So I went online and I asked myself, okay, we make a lot of plastics, but what is the thing that as humans we produce the most? So what do we manufacture the most? And I would like to ask you this question. What do you think it is that we make the most as humans? Does anyone have an idea? Yeah? Precisely. Very good. So this is pretty unanimous. I think most people online, if you want to Reddit or down different rabbit holes, you will find that mainly most people think that we make most of the things that we make is concrete. So we make about 400 million tons of plastics and 10 times more concrete. But if you think of the amount of concrete that you actually need for making a building, the density of concrete that you need, it looks like we make an awful lot of plastics. We all knew that, but just to put it into context, it's just too much. And because I said they're durable, they're recalcitrant, and they degrade very slowly in the environment, they're accumulating absolutely everywhere. And I'm not sure if you are familiar with this issue of the magazine, the journal National Geographic, that came out a few years ago. Did anyone see it? No? You may have it in your houses, maybe? Yeah? Okay, some yes. So did you notice that it was wrapped in a beautiful polyethylene film when it was released? Okay, so maybe the main point didn't come across as nicely as they thought it should, but the point that we're trying to make is that plastics everywhere, it's been accumulated in absolutely every niche, every environment in the world. And it's something that we need to tackle because obviously we all are familiar with the detrimental effects that plastics have for flora and fauna, and we are familiar, sadly, with pictures like this one, in which we see lots of microplastics, plastics accumulated in different types of environments. So today, we are not going to be talking about the big plastics, but instead, we're going to focus on the smaller particles. So these are called microplastics. By definition, they're smaller than 5 millimeters in size, but they can be much smaller than that, up to the level of nanometers. Now, we tend to think of them as the product of the decomposition of the big ones. And this happens a lot in the environment. So when the big plastics are weathered due to UV exposure or maybe shear forces, different mechanical processes, we tend to think they fragment and they make these smaller pieces. But a very important source of production of microplastics, of contamination with microplastics, is something that is what we actually wanted to explore in this briefing paper, are textiles, okay? So we use lots of plastics for making different types of fabrics, of clothes. These are made using fibers, and eventually these fibers end up in the wastewater. So lots of the microplastic pollution that we observe these days come from urban wastewater, and in particular they are related to the textile industry or textiles in general. Why do we care about this? We care about this because these microplastics go into the wastewater. Eventually, the wastewater is collected, is treated. All the solid particles, and this includes human debris, are used for making, after different processes, something called sludge, and this sludge is used in some countries, like in the UK, for making fertilizers. Okay, so this is organic fertilizer that we produce ourselves out of our own waste, and it's a great idea. The problem that we are seeing these days is that it's polluted with microplastics. Okay, so we only not have the problem of pollution of microplastics in the wastewater, but also by spreading these fertilizers into the environment, the microplastics can potentially go everywhere. And in this picture that I copied from the briefing paper, sadly, we don't have all the information that I was expecting to have. But you should see somewhere here, there is a wastewater treatment plant, and here there is a city. You have the picture in front of you in the paper if you want to have a look. What we've been trying to address are the different sources of microplastic pollution, and what are the different paths that these microplastics take into the environment. And one path that we have identified is this production of fertilizers and the use of the fertilizers in the field that eventually help the microplastics to spread into different environments. Okay, so that's the problem. Just to put some numbers into it, this, again, use of fertilizers is equal to the spread of the equivalent to 20,000 credit cards per month on fields, just because of the microplastic pollution present in the sludge. And something that we explore in the briefing paper as well is whether these microplastics are harmful or not. And we have more and more evidence that seems to suggest that they have a detrimental effect on human health. They can produce chronic inflammation, different types of respiratory diseases, and because sometimes they're also polluted by different types of additives, which could have other properties, they constitute a problem for ourselves. And very importantly, they are completely unregulated. So we do not know if there is something like a safe concentration of microplastics that we can have in the environment. And we anticipate that there might be regulation that could come into place in different countries to try to prevent very high concentrations of them, but it's something that as of today hasn't happened yet. Okay, not everything is bad, and we here at Imperial, together with many other groups in different universities, including some members of the panel, we've been working on, or we've been investigating microbial activities that are able to remove plastics from the environment. And what we are proposing is to use these microorganisms or enzymes produced by these microorganisms for the removal of microplastics in the process of wastewater treatment. And in particular, we think that this is a good idea because in the process of treating wastewater, there are already different microbial processes. So there are different types of digesters. So these are microorganisms that are either in aerobic or anaerobic conditions, are able to feed on different parts of the waste, the organic matter, in order to remove it and maybe even produce energy in the process. Okay, and we think that the use of these microorganisms under those conditions would be a way of removing microplastics and preventing their accumulation in the sludge that eventually is going to be transformed into the fertilizers. This is not wishful thinking, so I've prepared a video to try to convince you. Actually, I haven't prepared this video, but I have a video here to try to convince you that this is something that could be used for real. So it hasn't been recorded by us. So this is something that was recorded at the University of Leipzig by some collaborators in a European project that identified an enzyme that is particularly efficient at dealing with one type of plastic, that is PET, polyethylene terephthalate, okay? And what you are going to see here is how this tray is a post-consumer tray made of PET that comes from the supermarket. It's the normal one that you would see maybe used for packaging fruit, grapes or something like that. What you will see is how it eventually disappears because of the enzymatic action of this protein that was discovered by our collaborators. You have the timer there. It's a time-lapse movie. And that's the tray eventually dissolving. And then that takes about a day, 24 hours. On top of that batch, they can add a second one. And you can see how it dissolves eventually. And this is because of the enzymatic action of this esterase. It's an esterase. Okay? So we think it could be applied, or maybe potentially scaled up, for wastewater treatment as well. So just to finish, I mean, this wouldn't be a briefing policy paper launch if we didn't have recommendations. Okay? So our recommendations address three main things, and you have them in front of you. So the first one is that we need to understand microplastics better. So we need to know how many of them we have, what's the concentration, what are the different types, where they're coming from, and where are they going, okay? And for that, obviously, we need better methods of monitoring, standardized methods of monitoring, and in general, better surveillance programs. The second point is that we'd love to see, or we are advocating for establishing safe levels of microplastics. If there is such a thing, it might be that the safe level is no microplastics at all. And that's absolutely fine, but we need to know what is the impact in human health of these microplastics. And the final theme, we have a series of recommendations to try to develop new technologies, possibly using enzymes or microorganisms to try to get rid of microplastics pollution. This is something that we have working in lab scale. Some companies have been able to scale this up for industrial recycling of PET, but I haven't seen anyone doing this for wastewater treatments. And I have a final point here, is everything that I've presented so far relates to the degradation of polyester, so things like PET, but plastics are very different animals. And there are others like polyolefins, polyethylene, polypropylene, etc., for which we don't have technologies as good as the one that I introduced previously. So with this, I'll finish, and now back to you, Mara. Thank you very much.
Jose, thank you so much for that very interesting presentation. I think we'll go into our panel discussion now. May I invite the panelists to come up to the table? And while they're doing that, may I just give you a little guidance on questions for our in-person audience. If you could please save your questions until the end, we will have a Q&A session. Those joining online, please feel free to put your questions in the comment section at any point during the presentations, and a selection of these will be read out at the end during the Q&A session. We will now have the panel introduce themselves briefly, and I thought I'd just start with myself. Amparo's very kindly mentioned that I am from Imperial College, London, but I come from the School of Public Health. I'm a public health physician. I chair the expert group, as she mentioned, at WHO Southeast Asia region of the environmental determinants of climate change and health. And through that work, I'm only too aware of the enormous concern in the 11 countries that make up that region on the whole issue of plastics, and microplastics, and marine microplastics in particular, when you consider countries like Maldives and Sri Lanka and Bangladesh, where whole regions' livelihoods are being destroyed because of the level of microplastics pollution to be found in seawater and just literally everywhere in the environment. So I'm going to, who would like to be next? So Professor Andy Pickford, perhaps?
Yes, of course.
Please.
Hello, everybody. Yes, I'm the director of the Centre for Enzyme Innovation at the University of Portsmouth. Our centre is focused on the discovery, the engineering, and the deployment of enzymes for deconstructing plastics in support of what we hope will be a future circular plastics economy. Our work tends to focus on contained systems, where we break down plastics. It's very similar to the video that Jose showed in bioreactors, mimicking the way companies like Carbios would do it in industry and trying to make it better. But this, I think, is a fascinating potential avenue for utilising enzymes to solve what is clearly a very serious environmental problem.
Thank you, Andy. And Jennifer Hughes?
Hi, so I'm Jenny Hughes. I'm from UK Water Industry Research. You may have it as Thames Water in some of your programmes. It was previously at Thames Water, where I was looking at a variety of different research topics, including chemicals and microplastics, predominantly in wastewater. UK Water Industry Research, we are a not-for-profit organisation set up by the water companies for the water companies. So we are funded completely by them, but we provide independent and collaborative research to help all the industry answer some of the big questions. And microplastics is certainly on our list, both in drinking water and in wastewater and sludge, very much so.
Thank you, Jennifer. And now Dr. Steve Martin.
Thank you very much, and hello all. Yes, my name's Steve Morris. I'm from the Department for Environment.
Morris, I'm sorry.
That's okay. I'm from the Department for Environment, Food and Rural Affairs, DEFRA, and I am in the Floods and Waters Directorate, specifically in the water quality and contaminants teams. So part of my role is gauging and commissioning research to generate evidence to inform policy design, direction, implementation and evaluation. And one of my primary areas of interest is relates to environmental microplastics. And over time I've looked or examined standardization of methods to measure them in water and sediments, commissioned evidence reviews to understand their biological impacts on wildlife, and very much dedicated our efforts to supporting university studies to increase our evidence base to help towards that policy design in the future. Thank you.
Thank you very much, Dr. Morris. I think we're very fortunate today that you're here representing three major dimensions that need to come together: research, practice and policy. I just wonder whether you have any first thoughts, having heard Jose's briefing on his paper, from your point of view, and also bearing in mind the recommendations he put up at the end of his presentation. What are your initial thoughts? Should we go with you, Jenny, first?
First of all, it's really interesting, really exciting, and yeah, I think it's a global problem that's going to take a global solution. And we know that there are lots of different aspects of the microplastics problem. We can look at sources, we can look at pathways, we can look at receptors, but I think the key thing we have to think about is the harm to both the environment and to the public. And while this is, a really good start, I think there needs to be more people in this conversation as well. It's not just the engineers and the biologists. It's got to be a whole cast of people bringing this movement along. As I say, it's a global problem. It's going to need a global solution, and yeah, this is a really exciting step in sort of making progress in this field. We've talked about it for a lot of years. We've known about it for a lot of years, but I think we're starting to get to more of the solutions than just identifying the problems. So.
Yeah. Thank you. Steve, your point of view from
Yes,
government?
definitely. I mean, wastewater treatment in particular has always been targeted, but fortunately with microplastics and some chemicals, we do have that barrier for further discharge into the water. But the big question is, how do we manage the biosolids, and in particular those persistent particles of plastic? And also I'm very interested in the smaller materials, the nano-sized plastics and particles that are generated by further degradation, say within wastewater treatments and certainly within the environment. For me, this is a great first step forwards as a complementary tool to managing microplastics before they enter the environment, and I'm very much looking forward to the next 5 to 10 years as the project develops. My very first question would be, can the researchers focus on more than just PET or PET? Is there potential scope to look at the other polymers? And the other question is, they degrade the polymer to the monomer, what is the risk of the monomer? If that could be answered at some point through our discussion. Thank you.
Interesting. Thank you. Do you want to take that now, Jose, or just park it for a moment? Let's finish with asking Andy for his initial thoughts, and then perhaps we'll come straight back to you.
Yeah, I thought the paper was really comprehensive. There are lots of things that really stimulated my interest. One of them is that I think the first point about having standard ways of measuring microplastics is probably not the most headline grabbing, but it's one of the most important in my opinion, because we need to be really, really consistent in the way we measure both the type and the quantity of these things, so that we can survey different areas reliably and reproducibly, but also so that as we go forward in time, we can measure whether the problem is getting worse or whether our interventions are actually making any difference. So whilst that might not be the most headline-grabbing part of the science, I think it's really, really important that we spend some effort in doing that. The point about the breakdown products I think is a really interesting one as well, because we need to be conscious of unforeseen outcomes. In case of PET, Jose will probably answer this, ethylene glycol we know is a foodstuff for a lot of microbes, so it's not so much of an issue, but terephthalic acid I'm not so sure about. But there's also the catalysts that were in the polymer there from the first place. There's also the various dyes and additives that may have been added into polyester used for textiles. So, for example, flame retardants, maybe plasticizers as well. And by breaking down the polymer structure, we also release all those additives. So we need to be conscious that those are escaping. And of course, they would escape anyway over a very, very long period of time as the plastic is weathered and broken down. But we're going to be releasing them faster. So we need to be conscious of what the potential unintended consequences of those might be.
Thank you. Jose, do you have a comment?
Yeah, about the PET monomers themselves. As Andy said, I don't think they're much of an issue. So ethylene glycol tends to be not the best carbon source, but tends to be degraded by microorganisms in the environment. And something that we did in the past was to screen for terrestrial degraders. So terephthalic acid is the other monomer, and it's quite easy actually to find them. So I wouldn't be surprised if under the right conditions, so they need oxygen for doing this, they can simply be taken by microbial communities. In anaerobic digesters, we have no idea. We've never been able to identify one of these organisms able to take terephthalate. But you know, in principle, I would say they don't constitute much of a problem. Now, regarding the second part, or your first part of the question, working with other types of plastics is way more difficult. So anything that is not a polyester is way more difficult, as Andy knows as well. And for example, degrading polyethylene or polypropylene requires a series of different enzymatic steps that start breaking it down to an extent. Then the molecule eventually becomes a bit more accessible, and then what happens is the microorganisms tend to feed on the smaller parts of the polymer that are being released. So, but it's something that doesn't happen as fast as it happens with polyesters, for example. The additives is another big problem. We have a launch not that long ago actually discussing about the presence of additives. Some of those chemicals are very, very recalcitrant. And it's very difficult for microorganisms to be able to remove them. We actually don't know the biochemistry of those processes very well. So it's something that for which we need to continue investigating.
Thank you. Well, what that's illustrated is just the extraordinary interdisciplinarity of this challenge and the need for many, many people to come together. We've heard 3, 4 very different takes on this just in the last 5 minutes. So what are the gaps here? I mean, what else is needed to take this challenge forward and work to the recommendations Jose highlighted? And who should take up the initiative? Who'd like to begin?
Can I start by a question? Please. The presentation focused on enzymes. In your paper, you refer to bacteria as well. Is the research route going down the bacteria avenue to develop or genetically modify bacteria to challenge plastic material, or is it purely focused on enzyme and enzyme degradation processes?
Actually, both.
Okay.
The problem we have with the engineered microorganisms is that we are not allowed to release them into the environment. Okay, so if we are working in contained environments like fermenters, reactors, etc., you could use either or. Probably enzymes in our hands tend to be faster just because we can increase the concentration of them massively to improve the process, right? Whereas with microorganisms, they tend to struggle to survive, grow, and do whatever they're supposed to do. But in the environment, we are not allowed to use microorganisms. It may be ideal, but obviously unless that these are natural organisms, we won't be able to use GMOs. Unless that there is some sort of process that could prevent these microorganisms from escaping to the environment. And it's one of the points we make in the briefing paper as well, is some of the wastewater companies, they have procedures, they have treatments that they apply to the sludge in order to kill the microorganisms, so different types of thermal processes to try to sterilize the sludge. And that's something that in principle could work as well with GMOs. So you could think of using microorganisms or enzymes, but again, it depends on the conditions.
Just to finish off my little session, and if I may pass on to Jenny from the water industry side. But yeah, in terms of the genetically modified or the modified bacteria, one discipline would value or contribute very much to this work in the coming years would be the public perception of that engineering side of bacteria. Is it publicly acceptable? Do the public understand the principles and the implications? So I see social science research, public dialogue, as a discipline that could be integrated into the programme of work. If I may pass to Jenny, if that's all right, Chair.
Of course, absolutely. I completely agree with Steve. Social science has got to play a really part of this. The water industry, as I'm sure many of you will know, has had some pretty bad press recently, and we've got to turn a corner on that. The water industry aren't out there trying to do a bad job, they're trying to do a good job, but it's hard to do. But I think one of the things that we need to look at, not only solutions at water treatment works, but the fact that microplastics are created by people, and it's the source control element of all these things as well, and making people aware that they are part of the problem, but they can also be part of the solution. I know that some organisations have talked about fitting filters to washing machines to prevent microplastic discharge. Great, except when I take that filter out and run it under the tap, and then it's no better than it was before. So I think there's a really big education piece, but it's about bringing people along with the water industry and with all elements of research on this topic, and not sort of telling them that they are doing wrong, telling them, there is a problem, but between us we can fix this, or we can make a really big step in it. So I think for me, social science has got to be a really big part of not only this problem, but other issues that Steve and I and others talk about, chemicals in the environment. Again, they come from people. The water companies have to accept whatever is put down the sewer, whether it's good, bad, indifferent, and if we can stop those coming in, then there's not such a problem on what's going out. But in terms of other people to bring along on the journey, it's got to be our regulators, it's got to be our leaders, it's got to be, well, I can't think of anyone it doesn't need to be, unfortunately. Highways agencies, they're contributing via road runoff and things like that. So, every part of society has a role to play in the microplastics resolution, so to speak.
That's really interesting. I can see a big role for the commercial sector to come in here, because there's a question of whether people want it because they believe they need it, or whether there's a commercial interest in sort of persuading them that they need this level of plastics in their lives. So it's those are the sorts of things that social sciences might tease out, but we need the commercial sector there as well.
I think there's a lot of hidden plastics as well that people probably aren't realising. I mean, most people in this room and sort of involved in this topic will know it comes from washing your clothes, but do you realise it's probably in also the sun cream you're applying, the makeup that's being put on your face, anything like that. I know we've had the ban on wash-off products that contain microplastics, but there's still a lot of hidden stuff, and we're being told that we need that product because it has this benefit. And as we know, plastic does have benefits, but it needs to be in the right place, and it needs to be, you know, is it actually environmentally beneficial to have that, you know, just because it makes your eyelashes look longer and curlier, is that really the price we need to pay?
Jenny, thank you for that. Andy?
Yeah, really interesting points. One thing that occurs to me, which I'm sure others have considered as well, it is the need to get perhaps wider industry involved. And one of the challenges we have here is that there's no product as such. When you recycle plastic using enzymes or mechanically or whatever method, you have a product that you can sell and make money from. When we're just disposing of microplastics, there is no product other than perhaps the enzymes and the microbes themselves, which you can make money from. So I think we really need to think about the techno-economics of it. We need innovators. We need other industries to tell us how can we get people to invest in this in order to drive it forward. Because inevitably, money is what's going to make it, what's going to drive it forward. And as sad as it is to say that, it's the ability for companies to make a profit, which will drive this. So we really need to think a little bit more outside the box, I think, as to how we can get people to invest in these kind of technologies when there isn't an obvious product like there is for recycling. Sorry if that sounds a bit negative. It's not meant to.
Well, it's a challenge that you rightly, are thinking aloud about. And so then who should take up this initiative to bring all these sectors together? Bewildering range of people to be brought together, but it's the only way.
I guess it could be legislation that drives it forward, right?
This is correct, yeah. This is a very good opportunity to bring together the key stakeholders, the smaller and the larger stakeholders, to work collectively and less so in silos. And it has worked before and very successfully, so there's no reason why it shouldn't be done again. I think also we should be aware of chemical industry and their responsibility that they're taking for not only chemical products but also plastic materials derived from their processes. I'm aware, and from a hazard and a risk assessment strand of the work or of thinking, industry are working hard with UK, EU, international researchers in micro and nanoplastic areas to look at the harm that these materials do have, and from that harm to gauge and to estimate and determine the hazard assessment, the assessment of hazard, and further down to look at the risk assessment. So risk assessors within industry, academia would also be a major part of that process. To understand, especially the first part of the programme that you presented to us, having standardised methodologies to generate robust, unbiased data to enable hazard and risk assessment. So, but certainly the policy and the regulatory fields would be in a good position to bring together all the major stakeholders and the players within this field to collectively work in one direction for a positive managerial position to deal with these materials and to reduce and eliminate further discharge to the environment in the not so far future.
I think on that note, Steve, we don't need to wait for someone to take the lead. You know, there are so many disciplines that are already working on this, and you know, some of the themes that came out of it, you know, within 3 years we should have this, within 5 years we should have this. We are doing some of those things, and we can't wait for one person to finish their bit of research to define the harm, and then we'll move on to the next bit. We can't stand still on this. We've got to all start working together, and while we do need someone to sort of keep us all on track, I think, you know, there is so much good research happening we should carry on with, and we need more of, you know. It's not a problem that's going to go away by itself, unfortunately, and as we've talked about, there are lots of different aspects to tackling this, and yeah, while a steer would be great, I think there's a lot of good stuff already going on.
And I think the precautionary principle drives this without having a defined organisation group to push or to implement that drive. You know, it's well and truly embedded now. We don't fully understand the risks, but let's not hang around and have multiple strands of research, but bring that research outputs and outcomes together and work in that common forward direction.
Well, I see a role for government in that case. I mean, they're the only people who can bring together such a large group. And then, you know, I'm also minded, as a public health physician, as to the point you made earlier, and what do the public make of this? Often what they do is to see that, you know, one academic department is producing one kind of research, and then they think, well, those conclusions don't quite match somebody else's conclusions, so what am I to make of it? I'm going to mistrust all of this. But then, you know, is it not the role of government then to bring it all together and say, well, look, here's what the, you know, what the kind of sensible conclusion might be from all that's happening, and these are the things that are being taken forward, and both reassure and inform and sensitize the public to these issues. I can't see who else could do it.
That's very good, a very good point. And to give a good example of this, when I first joined DEFRA, I was involved in nanomaterials, manufactured nanomaterials, and there are proposals to use nanomaterials to clean up contaminated land, contaminated soil. And at that point in time, the evidence was lacking in terms of its efficiency, efficacy, and risks to the environment. And as part of my role within that work area was to bring together the public elements, and we did this via programs of working with the public over several months in terms of educating, introducing them to the evidence, and also carefully and scientifically bringing out their perceptions and understanding, and that strand of evidence contributed to our decisions on that particular policy in terms of let's still remain with a moratorium on the use of these materials in the environment until the evidence is up to a certain level of quality and quantity. So yes, government can play a very important role in that exercise of bringing stakeholders together, where there are policy ideas, designs being generated to deal with policy-based questions. So there is an important role for government to be involved in that process. Yes.
Thank you for agreeing, Steve. I think you've just given yourself another job to bring all of this together. May I also add, one of the issues is about getting research funders to understand the gaps, and that if we're talking about 5 or 10 years, we need to be doing the research now. So it's about using your power, I suppose, and the authority to request rapid responses to funding requests, so that bits of research and where the gaps are and questions are arising can be looked at more and more rapidly, because we're running out of time, aren't we? Yeah.
I see this more and more so over the past few years, that the engagement between UK research institutes and themes and DEFRA's opportunities, and other government department opportunities to design the theme that would develop the evidence base for the wider scientific community, but also simultaneously work to answering our questions, our research questions. And this is great to see, and I'm hoping this relationship between government departments and UKRI continue to work together to design that research pathway and themes to answer many questions. Can I ask, what is the appetite in the UKRI, other research institute fields for this particular area of research?
There is considerable appetite. There'll be a press release on Friday about new BBSSC funded mission hubs on tackling problems such as this. I'm not allowed to say any more. It's got to wait till Friday. But yes, I'm pleased to say that UKRI is really behind this type of work and is really committed to tackling what is a growing problem environmentally, health-wise as well. It's watch this space. But yes, UK is hopefully going to be at the forefront of developing the next generation of solutions to tackle these issues.
And so what's the role of Imperial then, Jose? Would you like to tell us a little bit about next steps for yourself and your team?
Have to watch this space again wait for the release on Friday. But we want to continue doing this research, of course. And I think something that Imperial does very well, thanks to institutes like IMSE, is to bring together people with very different types of expertise that are complementary. So for example, for this briefing paper, it's not only been the bio part, looking at the solutions, but we've also have civil engineers looking at wastewater treatment. We've had people from medicine looking at the impact in human health as well. So I see how we could continue to join forces and try to get a joint approach to tackle different aspects of this problem.
So is there actually any work going on the public health aspects of it, Jose? Is that what you're
Yes, one of the
implying? I'm
co-authors.
very excited to hear that.
So I don't know if we have... No. Okay, so one of the co-authors works precisely on this aspect, and she's been looking in particular at the impact in respiratory diseases of microplastics in air. So yeah, there is some research in this area at Imperial as well.
That's very encouraging to hear. Well, I'd like to ask a question about the Global South. Much of what we've discussed so far has been about solutions for what I'd call broadly the Global North, where there are, wastewater systems, there's a sewage disposal system, and there are these systems in place. And here are the challenges in the Global North. Is this technology likely to be applicable to the Global South? If so, now or sometime in the future? And what sort of solution should we be looking for? If we don't, aren't we going to be simply widening the global inequalities? And then there's the question of, we're all in this together. There's a lot of food imported from the Global South. I mean, just we're so inextricably linked, the Global North and the Global South. Could we actually leave the Global South out of this and not then end up disadvantaging ourselves through that? So how do we tackle that? Any thoughts?
Maybe we should start from base level in terms of the macroplastics that escape to the environment. Technological advances such as what's been proposed today would come later, but my first thought would be let's start reducing inputs of macroplastics, megaplastic waste into our river systems and further into our oceans, to reduce the environmental sources of plastics, which lead to more, over time, lead to more levels and quantities of micro-sized and nano-sized plastics, which will be just, as far as I see, because of the persistence, will be recycled and transported across large ocean stretches, and we will suffer, or it'll come north, and we're not addressing those far up sources. So my feeling would be to start with basic principles and address macroplastic waste, and utilising methods that the global north have worked on and now are in regulation. Can we do it at a sustainable level, or introduce those at a sustainable level within those nations of the global south, and help support, guide in a sustainable way that doesn't incur vast expense to the nation that is being supported and helped.
Well, thank you for that, Steve. Are there any collaborative research projects actually happening? Are you involved in any, Andy, or do you know of any?
I don't
With
know of
some
any that are specifically targeted at the global south. We do have projects that we're involved in looking at plastic pollution in Southeast Asia, for instance, which is has a really serious problem with coastal plastic pollution. And in particular, plastic caught up in mangrove swamps as well. And we have microbiologists who are sampling those plastics, seeing if there are any microbes of interest, but also working with local communities to try and find solutions. Completely agree with what Steve was saying. We have to reduce the amount of certainly unnecessary plastic that we're producing. Let's face it, what we're talking about today is part of mopping up the floor. We've got to turn off the tap. We've got to stop that plastic getting into the environment in the first place. It reminds me that the numbers that Jose said at the start, of this 400 million tons per annum that humanity is producing. I think when we bandy around these numbers, we don't really comprehend what we're talking about. I don't know what that number means, and I try and put it in different units. And the unit I use is Eiffel Towers, because everybody can kind of, well, if you haven't been to Paris, you've seen pictures of the Eiffel Tower, you know what it looks like, you know this is a big, big structure. The Eiffel Tower weighs 10,100 tons, so about 10,000 tons. So we're producing the equivalent in mass of 40,000 Eiffel Towers per annum. Now, that's an army of Eiffel Towers, 200 wide by 200 deep. I can't even imagine that. But if you stand those Eiffel Towers side by side, they'd stretch from Paris to the south coast of Nigeria. So that's how I think of the amount of plastic that we're producing on an annual basis. And it's only going to go up. Current forecasts say it's going to go up to probably 3 times that amount in 2050. We need to start turning off that tap. And if we can't turn off the tap, we need to start thinking about, well, how can we make our plastics more sustainable? We need, for example, innovations in polymer chemistry to give materials that give us the properties we need, but don't last for centuries if they leach into the environment. So we need innovations in that space as well. I'm sorry if I'm going off on a bit of a tangent, but I think these are really important things. It's all very well having plastics that can be recycled if you collect them, but we need them to naturally break apart and be degraded if they leak into the environment, which, let's face it, a huge amount of plastic, about a third of the plastic that's produced around the globe actually reaches the environment. I think maybe it's a bit less than that now. But it's a shocking proportion, and only a small percentage of plastic ever is closed-looped recycled back into new plastic. So we've really got to tackle the whole plastics economy and think about trying to undo some of the harm that we've done over the last decades since the 1950s, of making plastics effectively indestructible to nature anyway, the exception being the polyesters and maybe polyamides like nylon as well. But certainly the polyolefins, with a few maybe exotic exceptions, are indestructible to nature. and we have to stop it. We have to find a better solution.
Thank you very much, Andy. I mean, that was powerful, what you've just said. And I think as a public health physician, I can certainly confirm that the public need to hear more of these sorts of messages from yourselves, the scientists, you know, and they trust you to be advising them on the way forward for a more sustainable future, whether it's the environment or themselves. Jenny, do you have anything to add to this?
Not in particular. I can't say that the Global South is my area of expertise, but I think we need to make sure that it's not another topic where the North is steps and miles ahead of the South, and we are further increasing the gap on public health disparity. You know, if we're doing it and we are obviously, you know, all working towards the benefits of the environment and the public, we can't force our problems onto someone else. You know, just because we're not creating the plastics in the UK, we can't force other nations to produce those plastics for us to import. You know, it is a global problem, and it is that big global solution we need. We can't just, it's not here, it's over there, and we're just not going to look over there, and it's their problem to deal with. You know, we have to treat everyone as, you know, everyone's human and everyone is equal in that respect, and we can't leave people behind on this.
Thank you. I think it's now 4 o'clock, and time to take some questions from the audience. Would you like to raise your hand, and a member of our team will bring the microphone to you. And for those online, I hope you've been using the comments section to ask a question. And I know the team are collating them, and we'll read out some of them. So, yes, sir.
Well, first of all, thanks to everybody for a very interesting discussion. Just on one general point, the question about the you know, getting people together and so forth, I'm not sure that the government is the right answer. They're very good at talking their talk, they're not so good at walking the walk. They don't even seem to be able to get the water companies to stop discharging raw sewage at the wrong times. So although they might suggest all sorts of things, I think that the action needs to come from people like yourselves actually doing, you know, carrying out research and coming up with solutions that can then be presented as sort of almost fait accompli. My one question is, and I think it was touched on earlier, the demonstration we saw in the video had the plastic all sort of disappearing, but of course it doesn't disappear. It transforms into something else. And is there any research being done into what the residue is, or what the plastic transforms into, and to what possible health effects that might have, or just environmental effects, not necessarily just human health effects?
It's a very good question. I think it's back to you, Jose. Was there anyone else who might have an answer? Do also raise your hand if you have an answer, and we'll come to you. Jose?
I mean, about the first part and the involvement of the government, I'm afraid I'm not going to be able to comment on. But the second part, in the hydrolysis products, there are 2 things that can be done, and Andy can also expand on this. One possibility is to make fresh PET. And that's something that some companies do, actually. They use enzymatic recycling for making fresh polymer. The second option, and it's something that we've been investigating as well, is to use them for something called upcycling. So you can use the monomers that come out of PET hydrolysis, and we know what they are. So there's 2 chemicals only, terephthalate and ethylene glycol. And then use those to feed microorganisms or chemical processes, and then make other molecules of value. So they've been used for making things like other materials, different types of polyurethanes, for example. You may have seen in the news people making vanilla, vanillic acid out of them. So that was in the news not that long ago. So basically, use different types of metabolic processes to transform it into something else that could have a value and added value.
Thank you. Anyone else wants to add to that? No. Next question. There's a hand raised at the back.
Thank you. Not really a question, more a comment. You were talking about what solutions are there. Well, I would say go back to when I was a child. Milk today comes in plastic containers. When I was a child, it came in glass milk bottles, which were recycled. Today, fruit juices come in plastic containers. In my day, they were all glass. Now you go in to buy, say, something like a jam from a supermarket, some of them are still in glass containers, but a lot of them are now converted to plastic containers. The obvious answer is to go back to glass. Why not? It's recyclable. You can charge for it by adding a price onto the price of the drink, which is then, when you return the glass bottle, is refunded to you. What's wrong with that? It worked in the 50s. It worked in the 60s. Why doesn't it work in the 2020s?
Thank you very much. Really, really good observation. Any responses? Do we need the plastic?
I think we're all very used to a convenient lifestyle. I think that's the problem. You know, plastics, we coped before them. We've become very used to them. And there are obvious applications where plastics have vastly improved quality of life, medical implementation. But for a lot of uses, they're there because, well, they're probably a bit cheaper, but actually in the whole life cycle, they may not be the best thing. But I think this comes back to, you know, source control of all these things. If it's just not there in the first place, it's probably not going to cause a problem. Being in the wrong place, being broken down, you know, and it's the quantity of plastic as well, as you've discussed. We make so much and we're about to make a whole lot more by the sounds of it. I think source control has to play a part in this. I don't think it's going to resolve it, but I think it's got a really big part to play in sort of moving us along and improving the environment.
Thank you. Jenny, I think the source control will only come when somebody persuades them. This is the problem, isn't it? Because, as you said, it's going to be business as normal. I could just carry on. And yet the public are hungry. I believe, I don't know whether you'd agree, the public are hungry for information, advice, how to do things differently. I think there's a lot of anxiety about the environment out there. And I think they could actually be persuaded to use alternative containers and you know, look at how things were done.
Certainly.
Before plastic was literally everywhere. But then you'd have to bring the commercial sector and the sources along.
Definitely. Because quite often you'll find that it's only the premium products perhaps that are not in plastic packaging that you'll find in the glass or the other plastic is recyclable, but other recyclable materials. It is unfortunately consumer choice, and cost will always come into that, and if plastic is the cheapest for some people, that's got to be their only option. But also the convenience aspect. I've now got a glass jar, and what do I do with that necessarily?
Any comment, Steve, on that? We have a question. Yes.
Can I
yes. Yes, of course.
I do like your comments there at the back. I was fortunate to be brought up and grew up in the 1970s, and I saw this transition from metal, glass to plastic, and the plastic revolution. I think that the abundance of hydrocarbon resources has certainly increased the speed of plastic product development and globalization. And until that cost is brought in line with opportunities at society level to willingness to pay for materials slightly more expensive, such as glass, in terms of production, we're still going to see this emphasis on plastic supply and demand. Hydrocarbon resources play a significant part in that equation. equation and the cost of.
Thank you. Is there a comment there?
We have a question from online, from one of our viewers online, and it's very much picking up on these themes that we've just been talking about. It says, is there a place for applying the polluter pays principle here? For example, the transport industry is responsible for vast pollution of tyre and roadwear particles in runoff. So chemically speaking, that's another whole kettle of fish. If we just come back to the polypropylene and polyolefin, for example, and try and answer that bit, perhaps. The thing I'm slightly concerned about here is when we say polluter pays, that's all very well, but does the cost get passed on to the consumer? How do we make sure that the polluter actually pays?
I think the other corollary to what you're just saying is, could it be that the polluter pays principle disproportionately affects the least well off? You know, we were also saying, Jenny was saying, that, you know, some of the most expensive premium products might not come in those plastic containers. So that's telling us that if it is polluter pays and in some way the cost is passed down, it's going to be passed down to some of the people least able to afford it. So something will have to happen in order to ensure that there is equity in how that payment is made, I suppose. I'm thinking aloud here. Anyone else with some responses?
Certainly an area of interest for Uckware, and we're looking at it in terms of sort of chemical pollutants as well. I'm sure many of you will have heard of PFAS and things like that, and obviously sewage treatment works were never designed for any of these things to come through. They were designed for very basic, you know, sanitary determinants, clean the solids away from the waste. But the things that we're being given now, the microplastics, the flame retardants, the antimicrobials, all of these things they were never designed to do. So one of the things that we're looking at is what could we do in that arena? You know, where can we not necessarily portion the blame, but where can we best control these things? And, you know, source control, yes. Polluter pays, yes. Extended producer responsibility. They're all options we're considering. I don't want to say we've got any answers yet. We're still very early stages on this research, but it's a case of we are exploring the options, and hopefully they will give us some plausible and you know, possible solutions to start fixing some of these issues.
Thank you. We have a question here.
Hi, just regarding the last topic we've been just talking about. Also, I know that it is still possible in some parts of the UK to get glass bottled milk, and there's also a few kinds of refill shops that have opened up that I know about, where you can send your products, like shampoo bottles, to get refilled. And I think that that's probably also related to answering the question on why we switched from glass to plastic, and why we now, it would be nice to find a way of sort of switching back in a way. It's very hard to transport if you're using either glass or plastic as a one-use thing. Like, we buy glass bottles and then we chuck them in recycling, where they get smashed and remelted down and remade. It's still quite wasteful, whether it's plastic or glass. Both of them, recycling them by destroying them first and remaking is not ideal. But if you can actually just take the bottle and be able to reuse it, that's so much better. So I was wondering if you have any other thoughts on that.
Anyone?
I very much support that, and you see these initiatives in communities, and I'm hoping it's just a short matter of time it becomes a common practice amongst broader communities, towns, cities, villages, etc. It becomes a commonplace practice. How long that will take, I don't know, but it's the first steps. And you're right, the energy intensity involved in recycling, where it could be where a product can be used on a multiple basis. You consider the energy involved of dealing with that primary product and recycling it. We have the contribution to greenhouse gas emissions or to carbon emissions. And this is one area that we could focus on to to reduce those carbon emissions in that particular sector, so it has valuable benefits elsewhere.
Anyone else?
Yeah, I just wanted to add that we have these terms reduce, reuse, recycle, and they're in that order for a very good reason. If we can reduce the amount of plastic we produce, then of course that has direct reduction in energy use and resource use. Then what plastic we make, if we can reuse it, then that's the next best. And recycling does incur expense, both in terms of greenhouse gases and in terms of money and energy. And so that's the next option. But we should always be thinking of reducing and reusing before we recycle.
And there is, I suppose, the example of farmers' markets, because when they first began, I know it wasn't certain that the public would actually continue to buy from farmers' markets, but it's been sustained over time, and I think in that way, where you look at alternative ways of storing, purchasing household goods, people may be persuaded. It's about persevering, like the farmers' markets did, and keep at it until the public use that as a routine. So good idea. Thank you.
Hi, so a comment and a question. So first of all, just with the polluter pays principle, obviously in an ideal world it would work perfectly, but as we've seen a lot with carbon emissions, it doesn't always incentivize the behavioural change you want it to, as unfortunately the largest polluters can just pay the charge and don't see that much difference. But what I wanted to ask was, when you guys were talking about the global south and you mentioned a little bit about the macroplastics, could any of you expound on what you think the biggest barriers would be to rolling out something like this to tackle macroplastics that are existent in the ocean from a more potentially political or practical sense rather than just a scientific sense?
Very good.
Who would like to respond?
Sorry, can you elaborate on the initiative that you mentioned?
So you when you guys were talking about the problem with the global south, and mentioned the buildup of macroplastics in the oceans there, potentially using microbes to remove macroplastics that are already there. Obviously, that's a long way off in terms of science, but there would also likely be a lot of political issues in getting countries to work together to do that. Is there any way that any of you would be comfortable expanding on what barriers you foresee there? Because obviously a lot of this discussion has been very UK focused. Does that make more sense?
It does, yes. I could use an example of a visit to India once, and there was a cultural shock that ran through me in terms of littering, not only plastic material but other materials on the streets. And when I looked, it was older generations. And then where I was staying was having opportunities to chat with younger people, university graduates and people in their 20s and 30s. And the culture had seemed to have changed or is changing, and there's more respect for that behaviour, or not a disrespect for that behaviour in terms of littering. So it's a gradual shift between generations. So it's happening naturally within the state or within the country or within the zone. And maybe it's a generational, it would take a generation or two for that culture change to come through to a good position. So I'm answering on a more of a social level. And there are initiatives globally to support nations to manage chemical and plastic waste. So they're supported by departments for international development, across the global north, for instance, in collaboration with their counterparts in the south, to bring these initiatives into the nations, to introduce them to the scientists, the regulators, the governments, the public, to create that and develop that awareness of a need for change, and to give an example of how it can be done by using our experiences that we've gone through over the past 10 years or so here in the global north, as it were. So that, there's concerted effort and support and collaboration. If that answers your question, please. Okay, thanks.
Several hands going up.
I've got a question again from online. This is from somebody at a charity called FIDRA. This person says, we surveyed UK farmers on biosolids and found nearly all participants welcomed tighter regulation of contaminants, including microplastics. Do you see this research impacting biosolid regulation? Andy, you're nodding.
I'm nodding because it's a really good question, but I don't have an answer. I'm hoping, Steve, maybe you'd have. No,
I am, as a government official in this particular topic area, I'm unable to make comment.
Okay.
I think what I can say though from a UK water industry perspective is that the water companies are also doing research on these topics. We've got significant projects that will be starting from 2025 looking at the impact of spreading biosolids on soils and on groundwater, and we're also looking at treatment technologies for removal of microplastics from sludges. The water industry are absolutely supporting, further understanding this, and the thing that our regulators will always need is evidence base to be able to inform that policy. So the more research and the more useful research in this topic, absolutely welcome. And I think the water industry just want to know what their impact is. We're not here to say that it's not us. We just want to understand. But obviously, some of this comes back to those standardised methods. Without us all measuring the same thing and trying to put that into context with each other. You can be measuring weight, I can be measuring size, and we do need to come up with some of those standardised measures to make sure that what we're doing is all comparable, but we can't stop on that basis. We do all need to carry on this research.
Could I just ask a question? I mean, I think that sounds like a fascinating project, but when we're in the lab, we can control all the various parameters. How do you go about controlling all the parameters when you're doing this in the field?
We are assessing at the moment to find some suitable sites, because there are, different sites will have had different application of different quality over different timescales. So we are looking at how we can best control it and sort of do a site that has never had application versus a site which has had either continuous or we've got a good record of application. So we're controlling it as best we can, but it will be real world sampling. Yeah. So, sampling in the real environment. So we may have air deposition as well that we possibly need to consider. But we're trying a control and a sort of, a used piece of land, so to speak.
Thanks.
We'll be watching this space.
Absolutely. So the results will be out in 2027, I believe. So I'm afraid it's a little way off, but it takes a long time to get some of this research done well.
Thank you. Thank you. We had several hands here. One here.
Thank you. So I would like to ask about the practicality of using those enzymes and the microbes as well. So how much does it cost to produce these enzymes, and how stable are those? And also in terms of implementing microorganisms at the wastewater treatment sites, how difficult it would be to sustain them in the environment that you would put them in? I guess it would be more like a bio-augmentation of existing microbiology.
Do you have an answer, Andy, or would it be you, Jose?
Yeah, go ahead, Jose.
Well, maybe you can comment first on the enzymes.
Well, I was going to say on the cost of enzymes, I mean, we've been producing enzymes for many, many decades for many, many different reasons. And one of the things enzymes go into is washing powder. Of course, biological washing powder contains enzymes, quite a lot of enzymes, lipases and things to help digest stains. So we are very used to making tough enzymes that can withstand harsh conditions and can do it cheaply when they're made at scale. So I don't think the enzyme cost will be prohibitive. How you retain the enzyme in the environment you want it to work in, and whether, how robust it'll be to all this other stuff that's in the sludge. I'm only the expert on what that contains. I don't know. That would have to be tested. But Jose?
Yeah, about just to add up on the enzymes part, they are particularly good at dealing with plastics at high temperatures. So actually, the ones that are normally used are thermostable. So they are meant to resist high temperatures. So because under those conditions, the degradation is faster because the plastic becomes more accessible to them. So that's probably not the problem. A different aspect is the sustainability cost of creating those enzymes. And we've been looking into that a little bit. It'd be far better if we could have microbes that could produce them in situ, in that particular environment, as opposed to having a large reactor that contains water. So, it depends on where the energy comes from. It's not the same thing to produce in Denmark, where everything comes from renewables, compared to the US, etc. But, those are things that need to be taken into account. Now, regarding the use of whole microbes, it's something that's super interesting. We've done a lot of work on that. And there's always the issue of how they're going to be able to survive in the environment. That's very true. Now, the advantage that we have in sludge in particular is there is very rich in organic matter. So there's plenty of food for these microbes. And we have isolated microorganisms from soil that are able to happily use those things as food while they're producing the enzymes. A completely different story is whether they'll be able to kind of colonize the niche. And that's more like an ecology problem, but you're absolutely right. So these are things that need to be investigated further. A question, maybe a follow-up that I will have for Jenny is whether this would be feasible at all if we consider the scale of this operation, these anaerobic digesters, and whether the substrate could be accessible or not, because I suspect diffusion is very limited, and there is not a lot of stirring that we can do. But anyway, maybe it's a chat that we can have later.
I think there is certainly a potential for application. The scale, I suppose it depends how quickly, because you have to consider across the UK there are, I want to say 1,200 plus sewage treatment works, but not all of those are sludge treatment centres. So in quite a lot of cases you'll have smaller sewage treatment works where they will treat the liquid and the solid portion will be taken to another site for further treatment. So yeah, it depends how quickly you can scale all of this up, really.
We're nearly running out of time, so I take these two, and then sadly we'd have to come to an end.
Thank you very much. It's more a comment than a question. I just want to make a point on how the importance of measuring, and it's been said, but I think until a number is put in on the risk and the impact on human health and ecosystem health, I think the policy makers are not going to have an idea of how important it is to tackle the problem. If there is a clear number or a clear risk on human health or X number of deaths a year, like for pollution, air pollution, it's only when I feel I study microbiome, an expert microbiome, and I would love to see a solution like this implemented. But it's not until you see what is the impact and what is the risk. It's almost like going blind, because you don't know how much it's worth, how much money is worth to put in to tackle the problem. And then you can look into what is the most cost-effective solution and stuff like that. It's just to make that point.
Thank you. Okay, if it's a very quick question.
Sure, yeah. My question is more towards water companies, in a sense where it's quite clear that there's an environmental incentive to invest in the treatment of microplastics in sewage water and wastewater. But is there a more economic or monetary incentive or impact of microplastics presence in wastewater itself that's impacting water companies' operations that might incentivize water companies again to invest in kind of remedial technologies or anything like that? That makes sense.
I think the answer is so let me just get this right. So your question is, the microplastics risk to the environment is one driver, but what are the other sort of drivers? In terms of just doing the right thing for the environment, that's probably where we land. It doesn't, as far as we know, negatively impact our sort of treatment processes. Obviously, the products that we then produce, so the biosolids, we generally give away to farmers. We don't charge them for that. So in terms of that, it's not a negative to the water companies, but you know, we should be doing the right thing regardless of whether it's impacting our operations negatively as a water company, as the water industry, sorry. The main sort of principles are to protect the environment and to protect human health. So whether we're abstracting or we're discharging, yeah, we should just do it because it's the right thing to do in reality. And yeah, legislation obviously forces us to some extent to do something to meet a certain target, but there's nothing to stop us from starting that now.
Thank you, Jenny. And you know, of course, you know, it's the right thing to do for the environment. I think as the public health research advances, we're probably going to find some pretty profound public health effects.
I think that might accelerate.
That might end up being the equally powerful driver in the future. Well, on that note, I'm afraid I have to bring this to a close as we've totally run out of time. It's been a very bad chair. Thank you to our panelists for an excellent discussion and for responding to all of the questions so thoroughly. And also thank you to our in-person and online audience. Your questions have really enriched the discussion. Thank you very much to the authors of the briefing paper, Joanne Benton, Jose Jimenez, Alice Banks, Sarah Kakadelis, Kunyang Lee, Poheng Lee, Charles Romaine, Stephanie Wright, and Isabella von Holstein. A big thank you to all those who made this event possible, the AV team, the catering team, and the IMSE team. Of course, a big round of applause for everyone, please. Please don't forget to download and read the briefing paper, which is available in the link provided on YouTube or on the IMSE website, I believe. For those here in person, you can collect a paper copy. I think some of those are here. But also outside in the foyer, I think more paper copies are available. And for our in-person audience, please do feel free to join us now for networking and a drinks reception in the foyer. So all that remains for me is to say goodbye to our online audience and bring this event to a close. Thank you so much. Thank you.